We can also use the unit circle to evaluate trig functions for coterminal angles. So we remember that we can rotate around the unit circle as many times as we want in either direction, so we can get really big positive angles, really big negative angles. But when we're using the unit circle in order to evaluate these, we're going to need to scale those angles back, find their coterminal angle that actually appears on the unit circle, and then evaluate the trig function. So if we are finding or using the unit circle in order to find or evaluate trig functions for coterminal angles, we want to make sure that we first, one, simplify the angle to find the coterminal angle on the unit circle. So again, this means you're either adding 2 pi or subtracting 2 pi to the angle until you get something that appears on the unit circle. After you do that, then you're just going to evaluate the trig function at the coterminal angle. So let's take a look at what problems like this look like, how we would solve them. So we can say, let's use our unit circle to evaluate the sine of 660. So right off the bat, when I look at sine of 660 and I go around my circle, I don't see 660. I get to 360. That's it. So I know that 660 is bigger. It's an extra rotation around. So in order for me to solve this, the first thing I want to do is say, okay, 660 is too big, so I want to subtract a full rotation. I'm going to subtract 360. And when I do that, I get 300. So I'm really looking to evaluate the sine of 300 degrees. So I want to look and see, okay, what is the sine of 300 degrees? So I find 300, I go around my circle until I find 300. I know sine is my y value, so then I look at my y value. And now I know my answer is negative root 3 over 2. So the sine of 660 degrees is negative root 3 over 2. Let's try another one. So now we want to find the cosine of negative 11 pi over 6. So right off the bat, we know that our unit circle doesn't have any negative values on it. So we have two different options here. We can stick with our finding our coterminal, which we'll do that first, and then I'm going to show you a shortcut afterwards. So we need negative 11 pi over 6. We need the coterminal angle there. So we need it to be positive, which means I'm definitely going to be adding 2 pi, because if I subtract, I'm just going to become more negative. So I want to add 2 pi, but if I'm adding 2 pi, I need common denominators, which means this is really 12 pi over 6. When I add 12 pi to negative 11 pi, I get pi over 6. So I'm really looking for the cosine of pi over 6. So I go to my unit circle, I find pi over 6, and then I look for my x value because cosine is x, and I see that my answer is root 3 over 2. So now, anytime I'm dealing with a negative coterminal angle that I also recognize is an angle on my unit circle, kind of, if it wasn't negative, I can use the unit circle and my knowledge of negative angles, and I can just reflect and find that. So what I'm talking about is I see that 11 pi over 6 does show up on the unit circle. So if at some point I'm just getting a negative number or a negative radian value for one of my radians on the unit circle, I can use this shortcut. I can't use it if I was getting something that was not on the unit circle, obviously, because I won't have anything to reflect. But since I know that I need a negative 11 pi over 6, the answer on here, or the value that's on here, is a positive 11 pi over 6. So in order to find the negative value, I would take this and reflect it over the x-axis to get the negative, which is also the same thing as getting pi over 6. So you can either just add 2 pi, or you can find it on the unit circle and reflect it across the x-axis to find the coterminal angle and then evaluate the trig function. So that's your shortcut when you're dealing with negatives. All right, let's look at the last one that says the tangent of 11 pi over 4. So now, right away, I have a pi over 4, a 3 pi over 4, 5 pi over 4, and a 7 pi over 4. Don't have an 11 pi over 4, so I know I need to make 11 pi over 4 smaller. I need to subtract 2 pi, which when I make common denominators really makes that 8 pi over 4. When I subtract, I get 3 pi over 4, because 11 minus 8 gives me 3. So I'm really looking for the tangent of 3 pi over 4. So then I go to 3 pi over 4, and I pick out my y value divided by my x value, which is root 2 over 2 over negative root 2 over 2, and I know I have to simplify my fractions when I'm dealing with tangent, but this one simplifies nicely because my numerator and denominator are the same. One of them is just negative, so that means it's just going to be negative 1. So let's try one more example. Let's look at some reciprocal trig functions just to make sure you feel comfortable working with all of them. So if we're looking at reciprocal trig functions, we're still going to do the same thing. We're still going to come in, find the coterminal angle on the unit circle, and then evaluate the trig function. So if we look at the first one, cosecant of negative 2 pi over 3. Negative 2 pi over 3 is too small, so I'm going to have to add 2 pi, which is really 6 pi over 3. And I get negative 2 plus 6, 4 pi over 3. So I'm really evaluating the cosecant of 4 pi over 3. I could have also used my shortcut here, found 2 pi over 3, reflected across the x-axis to my other pi over 3, and gotten that it was 4 pi over 3. Now, once I figure out which angle I'm looking at, so I'm looking at 4 pi over 3, then I need to evaluate the cosecant. We know cosecant is the reciprocal of sine, so that means we're going to take our y value and we're going to flip it. So we're going to get 2. When we flip it, the 2 goes to the top, the negative root 3 goes to the bottom, but we have to rationalize that because we can't have a square root in the denominator. So we're going to multiply both of them by root 3. We're going to get 2 root 3 over root 3, and we did have, it was negative to begin with, so the whole thing is still negative. It's root 9 really, which is just 3 in the denominator. So my final answer is negative 2 root 3 over root 3. Let's try one more. So if we want to find the secant of 19 pi over 6, when we look at our unit circle, we see that 19 pi over 6 is too big, so we need to take 19 pi over 6 and subtract 2 pi, which is really 12 pi over 6. when we do that, 19 minus 12 gives us 7 pi over 6. So we're really finding the secant of 7 pi over 6. So we go and find 7 pi. Let's see, when we find 7 pi over 6, here it is. And then we need the secant is the reciprocal of the cosine, which is the x value. Our x value there is negative root 3 over 2. Oh, look at that. Same number as last time, right? We know when we flip it, we get 2 over negative root 3. And we know from studying our unit circle that a lot of these numbers repeat and a lot of our answers are going to repeat over and over. So it's okay that we got the same answer even though the question looks completely different because our numbers repeat over and over. So now we already know when we rationalize that, we really get negative 2 root 3 over 3.